All right, people, in the next experiment, we shall be measuring the resistance of the motor. And that's really easy because the voltmeters or the digital multimeters has the resistance measuring capacity. So let's see how that's going to be done. Okay, let me stop sharing the screen for a second. Okay, so this right here is our digital multimeter. I'm going to first of all put them into the ohms setting. So that is actually measuring the resistance. Okay, and the thing is that whenever you want to measure the resistance of any device, you have to make sure that it's not connected to anything else. Because if it's connected to something else, then you're measuring the resistance of the whole system, not just that device. So in that spirit, I'm going to unplug the motor. So now the motor over here is all by itself. The motor is not connected to anything. Yes, there's this power resistor in series with the motor, but this power resistor over here in series is like 0.01. How much is it? Yeah, 0.01. That's negligible. So here is our motor, and we want to measure the voltage and measure the resistance across the motor. May I request you to connect this, sir? Like just these two wires over here, please. So, yep. So this one is that, and then the other wire is connected. So what's the resistance value being read by the digital multimeter? Oh, so the motor resistance is about 2.5 ohm. That's what the digital multimeter is saying. Now, watch something. If I move the disk a little bit, it changes. Now it's reading 1.8. And if I move the disk a little bit more, this value changes. Now it's like 4.5. So what we're going to do is we're going to measure the resistance of this motor for various disk angle. Now, why is it that the motor resistance depends upon what angle the disk is at? Isn't the motor resistance just the resistance of the wires inside, the winding inside the motor? Well, that's something is for you guys to think about. And then that would be one of your post-lab questions, okay? But as of now, I'm gonna measure the resistance of this motor as I move the disk at various angles. So now, can somebody guess how many readings should I take? Like for what range of values of the disk angle should I be taking the readings? Why? Ah, somebody read the lab handout. Nice. Okay, so you see, the idea is if you actually spend some time on this experiment, you'll see that if you keep on rotating this disk, the resistance which you measure on the digital multimeter over here keeps on going up and down. And then after some times, it comes back to a full cycle. So the resistance is a periodic function. And it so happens that when you move this disk by 30 degrees, about 30 degrees, and that's when after every 30 degrees, the resistance graph repeat itself, because when you move this by 30 degrees, the motor completes a full revolution. Actually, was it 30 degrees or something else? So what is 12 multiplied by 30? 360. All right. So when you move the disk by 30 degrees, the motor has moved much more because of the gear ratio. So that's why I'm going to take the readings by moving the disk overall, bunch of readings in when the disk has moved over a range of 30 degrees. Okay, so that's for this experiment. And then we're going to then we're going to find the average value of the resistance. And all these things would be put in the table at back. So I'm going to choose different values, find different values of resistance for different angles moved by the disk over the span of 30 degrees for the disk, which is equivalent to over the span of 360 degrees for the motor. Okay, so we'll do the data collection now, and then we'll give it to you.